Good day everyone, welcome back to my YouTube channel. So today I will be implementing a graph. So I will be explaining it line by line and trace its output. But before that, I will be giving a short explanation about the graph. So let's get started. Now, what is a graph? So a graph is a nonlinear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges are lines or arcs that connected any two nodes in the graph. More formally, a graph is composed of a set of vertices and set of edges. The graph is denoted by G for graph and then open parentheses, E or edges, then V for vertices, then close parentheses. So there are two components of a graph. So as what I have said, the vertices and the edges, these are the components of a graph. So first, vertices are the fundamental units of the graph. Sometimes vertices are also known as vertex or nodes. Every node or vertex can be labeled or unlabeled. On the other hand, edges are drawn or used to connect two nodes of the graph. It can be ordered pair of nodes in a direct graph. Edges can connect any two nodes in any possible way. There are rules. Sometimes edges are also known as arcs. Every edge can be labeled or unlabeled. So now let's start implementing a graph. So first, this is our instantiation. And then next is this one. This is a method to add a new vertex to the graph. And the next one, this is where we add a new vertex to the graph by putting it in the map with an empty linked list as its associated value. So next is this one. So this is our method where we add a new edge between vertices. So here, this will be the one who will checks if the source vertex exists, and if not, adds it to the graph. So next, if statement. So this one will check if the destination vertex exists, and if not, adds it to the graph. So next, this one will add the destination to the list of adjacent vertices for the source. And here, if the bidirectional is true, adds the source to the list of adjacent vertices for the destination. So next, here, this method will define to count and print the total of vertices in the graph. So next, this one will be the one who will print the total number of vertices by getting the size of the key set of the map. And then this one, this is our method where we count edges. And then this one, we initializes a count variable to 0. Then this for loop, this is where we iterate over each vertex and adds the size of the adjacent list to the count. Next here, so here if the bidirectional is true, divides the count by 2 to avoid counting edges twice. So next here, this will be the one who will print the total number of edges. And then this one, this is the method where we check and print whether the graph contains a specific vertex S. So here, here, this will be the one who will check if the vertex exists in the map and prints the result. And here in our else statement, this will be the one who will print a message if the vertex does not exist. And next here, so here, this is our method to check and print whether there is an edge between vertices S and D. And here, so here, this will be the one who will check if D is present in the adjacency list of vertex S and prints the result. So in our else statement, this will be the one who will print messages if there is no edge between the vertices. Then this one, this is our override the toString method to provide a string representation of our graph. So next, so this is our string builder to build a string presentation. So next, in our for loop, so here is our for loop. This will be the one who will iterates over each agent adjacent vertex and appends its string representation. This will be the one who will iterates over each vertex and appends its string representation followed by a semicolon. And then next, this will be the one who will iterates over each adjacent vertex and appends its string representation. And then here, this will be the one who will append a new line character after each vertex and returns the final string representation. Then here, this is our method, which is public class named graph implementation. So next, this is our main method where we start our program. So next, this will be the one who will create an instance of a graph class. And then, so in this line, this will be the one who will print the adjacency list representation of the graph. And then so here, this is where we print the total number of vertices and prints the total number of edges considering bidirectional edges. Next is checks and print whether there is an edge between vertices 3 and 4, and then checks and prints whether there is an edge between vertices 2 and 4. And then next is checks and prints whether the vertex 3 exists in the graph, and then check and prints whether the vertex 5 exists in the graph. So here, this will be the one who will print the agency list representation of the graph. And the next, this one will print the total number of vertices. And then this one will print the total number of edges considering bidirectional edges. The next is, this will be the one who will check and prints whether there is an edge between vertices 3 and 4. And the next is checks and prints whether there is an edge between vertices 2 and 4. And then this will be the one who will check and prints whether the vertex 3 exists in the graph. The next, this will be the one who will check and prints whether the vertex 5 exists in the graph. So this is our closing for our main method. And then the next curly brace will close the implementation of our class. So now this is the result or the output. So agency list for the graph. So let's find it in. So here, using system.out.print, it prints the message which is agency list of the graph with this one. And then next is the total number of vertices. So here, so using this looping and then system.out.print, which prints the message total number of the edge and then the value, then total number of the edges, which is 8. So in our total number of vertices, so this is the one who prints this message and its value using this. So next, there is no edge between 3 and 4, so